Welcome, students. Uh, in our last class of ecology, we had studied, actually started population ecology, and we had studied some of the important terminologies like the what is population density, and what are actually the factors like mortality, natality, population dispersion pattern. The important feature of population study is to study the population demographic features. Demography is actually the study of factors that affect the growth and declination of a population. Any type of factor which directly affects the size of the population is actually the demographic features. And sex ratio and age structure are two important demographic features. So, what and the persons which study the demography are actually called as demographers. So they have a wide range of aspect in demographic study. Like they study the size of the population, they study the density and distribution of the population. They study the age structure and the sex ratio, even the birth rate, death rate, immigration and emigration rate. But of all these factors, age structure and the sex ratio are the key factors behind the demographical studies. So this slide is also showing the population density or population size of different countries of the world, and the leading one is the China, and the second one is India, and there are some important some other countries like US, Indonesia, Brazil, Pakistan, Bangladesh, Nigeria, Russia, Japan, Mexico having high number of population size of humans. So we will study now we'll focus on the sex ratio and age structure. Sex ratio is actually the proportion of males to female in a population, and in a monogamous population or monogamous species, the sex ratio of 50 is to 50 maximize the population growth. That is the ratio of the males and the ratio of females, or we can say the ratio of actual breeding males and actually breeding females must be equal. If there is a difference in the sex ratio, then it will lead to the size of the population will not grow in the manner in which the maximum growth which is possible at equal ratio. So, and in particular in sex ratio, the ratio of female is more important because the females are directly associated with births. So the ratio of female should be high if for a population to be to increase in near future. Age structure is actually the relative number of organisms of each age group within the population, and the age structure are actually the best described by age pyramids. So this is the ratio of males to females. The primary sex ratio is the ratio of at the time of conception. Secondary sex ratio is the ratio at the time of birth, and the tertiary sex ratio is the ratio at the time of maturation of organism. So again, the sex ratio has been divided into three categories, like primary sex ratio, secondary sex ratio, and the tertiary sex ratio. So the human sex ratio is of particular interest to anthropologists and demographers. Anthropologists means the individuals which study the human populations and aspect related with the evolution of human population, the size of the population, and they are actually called anthropologists. In humans, the secondary sex ratio is commonly assumed to be 1:05 boys to 100 girls. You can the data is available in this slide. You can study the data of the secondary sex ratio as well as tertiary sex ratio. So now we will focus on age structure. Age structure is actually the relative number of individuals of each age group in a population. Populations are classified into three different age groups: the pre-reproductive age groups, the reproductive age group, and post-reproductive age group. Means these age groups actually defines the they are important in the sense that which age group is dominant in a particular population will ultimately decide the future of that population. For example, if the number of pre-reproductive age group individuals is more as compared to the reproductive and post-reproductive age group, it means this population will expand in near future. And suppose if any population having a post-reproductive age group number is more as compared to reproductive and pre-reproductive age group, it means the future, this particular population will decline in near future. Or we can say in simple word, pre-reproductive age group means individuals which are actually right from birth to the time period of puberty, where they achieve their reproductive potential. So that particular time period, from birth to achievement of the this particular reproductive potential, is called as pre-reproductive age group. Reproductive age group means where the individuals are reproductively mature and and possess potential to reproduce and produce fertile, viable offsprings. They comes in the reproductive age group. For example, if we talk about the human population, then you can consider that right from the birth of a human in individual, that is from up to 17 to 18 years, or we can say 16 to 17 years of their life. First 16 to 17 years of the life is actually can be categorized as pre-reproductive age group, and from 16 to 17 to 40 to 45 years, in particular for females, this particular age group will be called as reproductive age group, and beyond that 45 or 50 to 60, 70 or 80, whatever it may be, is called as actually post-reproductive age group. So age structure is applicable only in overlapping population, not on non-overlapping population. Further, it is important that the age structure, now population can be categorized on the basis of whether the generations are different generations are living together or not. On this criteria, the population may be overlapping population and population may be non-overlapping population. Overlapping population is the population in which individuals of different age groups are living together. For example, human population, कि हम जानते हैं कि ह्यूमन पॉपुलेशन के अंदर ह्यूमन पॉपुलेशन एक ओवरलैपिंग पॉपुलेशन है, जहाँ पर अलग अलग पीढ़ी के लोग एक साथ रहते हैं. जैसे कि आपके दादाजी भी हैं, आपके पिताजी भी, आपके दादाजी एक अलग जनरेशन के हो गए, आपके पिताजी एक अलग जनरेशन के हो गए, आप खुद अलग जनरेशन हो गए, तो तीन पीढ़ी एक साथ रह रही, तो दैट इज़ कॉल्ड एज ओवरलैपिंग पॉपुलेशन. इस तरीके से नॉन ओवरलैपिंग पॉपुलेशन मीन्स ऐसी पॉपुलेशन जिसमें सारे के सारे जो इंडिविजुअल्स हैं, दे बिलोंग्स टू सेम एज ग्रुप्स. They are very small they are actually small organisms, small individuals. Just for example, in case of प्लांट्स, द सीजनल प्लांट्स, जो एक पर्टिकुलर सीज़न में ही ग्रो अपना पूरा लाइफ साइकिल कंप्लीट कर लेते हैं, कि बारिश के सीज़न में उनका जर्मिनेशन हुआ और उन्होंने सबसे पहले अपनी वेजिटेटिव ग्रोथ कंप्लीट करी, वेजिटेटिव ग्रोथ के साथ ही रिप्रोडक्टिव ग्रोथ कंप्लीट करके और नए सीड्स बना करके और वो ख़त्म हो जाएंगे. और वो सीड जब अगली जनरेशन में आएंगे, अगले साइकिल में, जब अगला वर्ष वापस बारिश का आएगा, तब वापस बीजों का स्फुटन होगा और एक नई पीढ़ी आएगी. तो तब तक तो उस समय जो इंडिविजुअल्स रहे होंगे उस पर्टिकुलर सीजन में, वो सारे के सारे एक ही पीढ़ी कहलाते हैं. स्मॉल इंसेक्ट पॉपुलेशंस, एंड दीज आर एक्चुअली एग्जांपल्स ऑफ नॉन ओवरलैपिंग पॉपुलेशंस. So this slide is showing the नॉन ओवरलैपिंग जनरेशंस. मतलब जैसे फॉर एग्जांपल जनरेशन 1 में बर्थ हुआ, मैचुरेशन हुआ, रिप्रोडक्शन हुआ, डेथ. फिर अगली पीढ़ी में वापस बर्थ, मैचुरेशन, रिप्रोडक्शन एंड डेथ. तो ऐसी जनरेशंस जो है, these are actually non-operable generations. So this is the slide which is showing some pictures of overlapping and non-overlapping generation. You can see like elephants and birds, actually they are actually overlapping generations. These populations belong to overlapping generations. And like small insects and small plants or seasonal plant, or we can say they are actually of example of non-overlapping populations. Now, population age structure is best defined by the age pyramids, and age pyramids are actually graphical representation of the individuals of different age groups. And the different age groups are what? The reproductive age group, the reproductive age group, and post-reproductive age group. So it is the graphical representation of these three age groups. So there are three different type of age pyramids. One is called as broad shape pyramid, which is actually called as expanding pyramid. Second one is a stable pyramid, and third one is declining, which is called as unshaped pyramid. And the stable is also commonly known as bell-shaped pyramid. So expanding, stationary, and contracting. So in case of expanding pyramid, the number of pre-reproductive age group individuals is more as compared to reproductive and post-reproductive. You can see in the slide that the number of pre-reproductive age group is more as compared to reproductive, and the post-reproductive individuals is further, the number of these post-reproductive individuals are further less as compared to reproductive and pre-reproductive. It means the birth rate in such population is more as compared to death rate. So natality is more as compared to mortality. It means this population will increase in near future. So it is actually an population which is expanding. Human population is actually expanding population. So it show broad shape pyramid. But in case of stable population, the birth rate and obviously death rate and their respective age groups जो number है, that is more or less equal. So it is stable. The birth rate actually matches near about to the death rate. So such type of population is actually stable population. They will neither increase nor decrease in the near futures. While a declining population in such population, that is also called as urn shaped pyramid, in which the birth rate is less low as compared to the death rate, and so the number of new individuals are comparatively pre-reproductive individuals are comparatively low as compared to reproductive and post-reproductive individuals. So such population will decline in near future as well. And most of the threatened populations, threatened species are actually a very good example of declining population. For example, cheetah population in Africa is a very good example of a declining population. Now, population life history traits are again very important of characteristics by which we can compare different types of population, and on this basis, population on this basis of on the basis of life history traits, we can categorize population as simultaneous population and heteroparous population. Now, what are the traits actually which are used to define the life history? Life history means more or less how a population lives in a given environment. So these are some of the important characteristics which जो कि, and these important characteristics are what, like this: the age of reproduction, that is age at first reproduction. Okay, what is the what is the age where population, the individuals of a population reproduce, that is maturity. Some individuals maturity reproduce at very later age. Some individuals reproduce very early. इसी तरह से second one is number of reproductive events during the entire lifespan, but that is called as parity. The individual's population, in some population, the individuals reproduce only once or only single during their entire lifespan. So their parity is simply 1. And there are some populations, there are maximum populations which are, for example, the population of animal plants, mammals, birds, and reptiles, and all this vertebrates. The individuals reproduce multiple times during their entire life. So their parity is more. Then number and size of offspring produced during one reproductive event. During one single reproductive event, how much number of individuals are actually produced? That is also known as clutch size. The clutch size may be small or clutch size may be large. In some cases, clutch size is large. For example, during a single reproductive event, the insect pair can lay hundreds of eggs. But in case of mammals, the clutch size is few. For example, in case of humans, the clutch size is single, or in rare cases it may be 2. And further, the parental care, whether parental care is present or not. In some population, there is no parental care. After giving the birth to the individuals, the parents move here and there. They do not care for their offspring. While in case of in many cases, there are some many cases populations do care. The parents do care about their child. For example, mammalian population. In mammalian population, there is strong parental care. In case of insects, there is no parental care. So on these life history features or life history traits, the population can be classified as a simultaneous population or heteroparous population. Now, what is simulparity and what are actually simultaneous population? They have age at first reproduction very early, means they contribute their maximum energy in the single reproduction, and this reproduction is very early. They only reproduce single time during the entire life, and during that single reproductive event, they produce many offsprings. That is, they have large clutch size. Parental care is totally absent. Lifespan generally very short. So most of the insects, invertebrates, animal plants, and many fishes are the example of simultaneous population. In case of heteroparous or heteroparity, the age of first reproduction is delayed or very late. They have multiple reproductive events during the entire lifespan, so parity is more. During the single reproductive event, they produce a fewer offspring, that is small clutch size. Parental care is extensive, that is present, and lifespan is generally large, is long. So such type of heteroparity or life history traits are characterized by populations of mammals, most vertebrates, and perennial plants, including humans. So this is again a simple comparative analysis between the similarity type of life history and heteroparity type of life history. So in similarity, you can say they reproduce once and produces many offsprings, and most of the offspring die during early stages of their life, and offsprings are on their own. That is, there is no parental care. While in case of heteroparity, the populations, the individual population reproduce repeatedly, and during one reproductive event they produce few offsprings. Most of the offspring survive because there is extensive parental care. Offsprings are cared for by the parents. Now, survivorship curve. Survivorship curve are the curves which actually describe the number of survivors, that is, number of surviving individuals in a population at different stages. That is, at different stages of life cycle, or we can say the number of survival of population at different age groups. We can say if previously we had taken three different age groups: reproductive, and post-reproductive. So this is again a criteria of a comparative study between different type of population, that is, number of survivors at different age groups. So there are three types of survivorship curve. That is type 1 survivorship curve, type 2 survivorship curve, and type 3 survivorship curve. Type 1 survivorship curves are characterized by high survival in the early and middle life, followed a rapid decline in the survivorship in later life. Humans are one species that show this pattern of survivorship. Means in type 1 survivorship curve, the mortality rate is very low during pre-reproductive and reproductive age group. So most of individuals takes which take birth completes their the uh, pre-reproductive lifespan as well as reproductive lifespan, and the mortality is mainly increased during the last stage of their lifespan, that is, during the post-reproductive age group. So their curve is like concave curve, highly concave curve. In case of type 3, जो है, the greatest mortality is experienced at the early stages, है ना. And once, for example, 1,000 eggs are being produced by insect, so out of the 1,000 eggs, only 100 eggs actually survive, and the 100 individuals will complete their lifespan, while the 900 eggs or the offsprings actually dies at very early stages of the life. So once the few individuals which actually survive, they then complete their lifespan. So the mortality is maximum at pre-reproductive age group, and then it is less in reproductive and post-reproductive age group. So such type of curve is actually called as highly convex curve, and basically the populations which show similarity type of life history actually belongs to type 3 curve, while type 2 curves are actually intermediate between type 1 and type 3, where there is a constant mortality rate observed in all lifespan at the whole lifespan, that is, whether it is reproductive age group or post reproductive age group. So type 1 and type 2 curves are actually showing the heteroparous type of population or heteroparity type of life history traits. You can see how the graphically the survivorship curve can be explained. When the red line the red curve is actually the type 1 curve. Humans are the best example. The mortality rate is very low in case of early stages. The mortality increases during the later stages. So at one axis, that is towards y axis, this is number of survivors. That is, for example, at start thousands individuals are 1,000 individuals are being born of either it is a human or it is a rabbit or a squirrel, and it is an oyster or any invertebrate. So out of 1,000, you can see most of the 50% of individuals that is, we can say, actually thousand can are competing their uh, first stages of life in case of humans, in case of first type 1 survivorship curve, while there is a high level of mortality in type 3, you can see. And once the survivors, for example, there are 10 or few survivors, then 10 survivors out of these 1000 survivors, then they complete their entire life full, while there is constant mortality rate in case of type 2 survivorship curve. So this is all about today's class, in which we started uh, the population demographic features, where we discussed the two important demographic features like age structure and the sex ratio, and how these age structure and sex ratio is responsible for the change in size of the population. Then we studied the important life history traits. There are two different type of life history traits, that is heteroparity and simulparity. On this basis, the population, we can divide population as, or classify population as simulparous population or heteroparous population. And finally, we had studied the survivorship curve. Type 1 and type 2 survivorship curves are actually the characteristic feature of heteroparous type of population, and type 3 survivorship curve is a characteristic feature of simulparous type of population. Thank you.